Okay, let's start. Thanks, Michael, for reminding me for recording. Um, okay, so we have a few things to cover today, and hopefully you're making progress in your project and also in your lab. Um, by end of this week or by Monday, we will give you instructions on specific instructions on your Lab 9 assessment, but I've already explained in the last lecture what kind of questions you may have roughly. So as far as you have done all your exercises, you know what your solutions are and you understand them, that's all we need to check. We will be asking similar questions, but the topics are very much restricted to what is covered in the lab exercises. Okay, please ask me if you have any questions. Now, today we were just going to continue with the exception example, which we almost finished, but there were like one more angle I wanted to show you today. I've already released this code, and the other example we'll quickly go through, which is also available to you anyway. And then we have one more topic to cover in this lecture, and then we can move on to the next topic. Okay. So we stopped here yesterday, and we basically says that there is a function which is throwing input output exception, in which I'm doing something with the file. Exactly what we're doing is not that great, but doesn't matter. You're opening a file for writing and you're writing something into the file. The idea is that if something goes wrong, this statement or this statement, one of them may throw input output exception, and then in this case, because the method is also throwing the exception, the calling program needs to basically handle it. So the calling program needs to catch that and do something. Okay, that's what we're doing. So all is fine. The tricky part here is that I'm opening a file. Now, if something goes wrong while I'm writing something or anywhere in this part of the program, then because it will throw exception, it will immediately leave this method, and it will then the control will then be transferred to the calling program. So therefore, we never end up touching this statement or even particularly close file. So that file is still open. So as far as you're consuming resources, you don't want, generally speaking, we have finite number of connections available, so we want to close that resource, or you want to get rid of all the resources you don't need. So what we should have done, rather try, and you should have actually slow. Okay, so I should have tried that, and then I should have said here finally, and then I simply go and put this code there. So even if there is an exception, you exit this particular, you know why it's, but there's a delay in which what I do. Okay, so as you can see, with extra bracket there. Okay, so come on, man, pretty slow here. Come on, there's one extra. I mean, curly bracket is missing. Delete that. Okay, so it basically, so one bracket was missing. That's why finally wasn't recognized. Now you don't need to have catch. So in this case, it is doesn't matter even if I need to leave this somewhere during the catch part. it will still go and execute these two lines. And as I've indicated, what if out is actually not even initialized? Okay, so generally speaking, the good practice would be actually go, otherwise it will say null pointer exception. So you say if out is not equal to null. Okay, then okay, okay, so you protect it. So if not null, then only close, otherwise you don't close that. Okay, so that's very critical. So it can be a bit subtle at times. It will basically stop the flow of your logical algorithm. So your logic part is only here. Rest of the part actually just making sure that if there is an error, I close and so on and so forth. So yeah, some people not necessarily like it, but it is an essential aspect of any programming language for that matter to handle errors and exceptions. Okay, there's another example which I'm not going to go through right now in detail, but I've already made it available to you. Not another, the same one, but more explained. Okay, and that example is this. Okay, so that example, yeah, one thing I need to show you. So that's a similar same example as before. Okay, so here we don't use finally. I showed you this is not a necessarily good idea. Now, so there's another version in which we are catching everything locally, and then we have finally also. So the different variations here. Okay, now this example shows you, they also have this example for read file, but more importantly, we can create our own exception. Okay, so the idea is that if you want to create your own exception, so this is all you need to do. You create a class called, say, my exception, and that extends a class called exception, which is already available in Java. Okay, so generally speaking, so of course that's a subclass, so I can consider that also as an exception. So I can create an object of this type and I can throw. This is our own exception type. Now, we generally need to, because of the concurrency issues, we generally also, not generally, we need to provide serialized version UID. I don't want to get into that much in detail, but you can just take the default value and that should be fine. It will insert it for you. But that is to do with serialization, which is beyond the current discussion because we're already a bit behind. So basically, you can write whatever you want to write here. But mostly what we provide, uh, no, it's basically a number. You can create it by default, it's one. Otherwise, you can have another serial number also. So I said to you, it's we're getting into serialization, but no, it doesn't have to be one. It can be some other number if you prefer. So, but you can use default value, and that will work for our purposes. Now, you basically can have whatever number of fields and methods you want, but generally speaking, when you create an object of that exception, at the time of creating that object to represent that exception, we provide some information. Say, hey, something like this went wrong. So you want to have some information associated with that exception. So normally when you create that object, we provide a constructor, and one of the thing to do is to basically say, the argument is a message which we are going to store in that object. So whenever I create an exception, I can provide a message. So later on, when somebody catches that object, they can go and use get message and they can retrieve that message. Now, if you want to pass more information, by all means, you can have more arguments here. You can have multiple constructors, more private variables, more get methods for the corresponding variables. That's all up to whatever you need. But that's just the basic example. Now, the way to use that is, as you see, and this is I'm just artificially showing you, somewhere we are saying, you see in this example, we are even catching unchecked exception because that's what I want to do for my logic. So I say even if it is index out of bound exception, which you don't need to catch, but I don't want program to crash, so I just catch it and print some message. Okay, for example, so we can do that. That's what checked exception we have to. Interestingly, I'm just putting some logic. Of course, that's very artificial logic, but we say, well, okay, if some criteria is true, in whatever criteria in your program, something has gone wrong logically. So you say, hang on, I want to throw an exception now. So far, we were assuming that this particular statement will throw exception. Now we are throwing. So I'm throwing exception, throw, new. All I need to do is create an object of type exception. That's it. That means object of any class which is a subclass of that also. And at that time, this is the message we are passing. This is our string, we can create whatever string we want to create basically. Okay, so that's all we need to do. So for example, if this condition is true, so in this case it will be, because we are just saying value is 15, so it will throw the exception. So when I'm going to call this function in test, so when I'm going to run this program, okay, so when I'm going to run this program, you see, when I execute this method, it will throw the exception. So now I'm going to catch that exception here, because it's check exception, so it will ask me to uh, catch that exception, and then I can do whatever I want to do. I can get that message and print, or this will print the entire stack. So yes, if you really want to deal with invariants or whatever others, yes, you're right, you'll be creating your own exceptions. That's exactly right. And then when you, of course, when you create exceptions, you want, I just said my exception, but in your example you would put a meaningful name to that exception. Now there are couple of approaches to this. One of them is that, I just create one exception class, which is what we discuss here, and I assume that whenever I'm going to throw exception, at that time I will add the corresponding message. So somebody catches the exception, they look at the message and find out what kind of exception is that. So there are three invariants in your program. So instead of having three different exceptions, you say my invariant exception, and then which one is it? Well, you say I'll check the string and find out. That's one way. Not necessarily a good way, but that's one way. The other one is to actually create three classes: my invariant one exception, my invariant two exception, my invariant three exceptions. The advantage of that is that just by looking at the object type, you immediately know what it represents, meaning that invariant two has failed somewhere. That's why this exception is coming up. Okay, so generally speaking, we can have a different type to represent a different message. So just by looking at that, you can find out what kind of error has taken place. Alternatively, also, you can have one extra layer and check the message and decide what has gone wrong. Either way, you can approach this. Okay. And by the way, also remember that you can also use hierarchy here. So you can have my uh, invariant exception, and which extends exception, and then invariant one exception extends by invariant exception. So therefore you can then treat all these exceptions under one umbrella, and that's what I'm going to talk about. I can zoom in surely. Okay. Doesn't that's the smallest one. It doesn't like me to. I'll just go a little bit. Yeah, but how can I decrease? How can I get rid of this explorer? Yeah. Okay. Okay, can you see that now? I hope that's fine. Okay, okay. So that's how you can write your code. Where was I? Okay, it's very slow. It's lagging quite a bit here. Okay, so I think I've just shown you that you can write our own exceptions. Now, one more thing I wanted to show you is, see, I am catching one particular exception here. I'm catching IO exception here. Okay. Now, it is object-oriented programming. So the way it works is that it will start from the first catch statement. If it matches, you execute the corresponding code and you leave the catch statements. Okay. So of course, these are two different classes, so there is no problem. But if I don't want many catch statements, you can also simply do exception. Because remember, all these exceptions we just created, okay, they are actually subclass of exception. So each of these objects can be treated as an exception. So immediately it gives me error message here because it says, hang on, there are only two type of exceptions coming out of the try. One is IO exception and another, I start check so it won't even notice it here. And IO exception will be caught here because exception is a super class of IO exception. Therefore, I will never come here. Okay, so it says you don't need this now, and now this will catch even the any kind of exception. It will catch basically here, which is the subclass of the exception. So you don't need to always have. Normally, it's a good idea to have catch for every different exception, and accordingly you take action. Okay, but if you want, you can basically have one super type which catches more than one different types of exception and with that accordingly. That's your design choice. Either way, okay. So I just wanted to show you that. Okay. So any question you have right now? Okay. So okay. Okay. Now, but when we have a super class exception catch statement followed by a subclass exception. Now, it's only if the first matched one will be executed. Okay. So if you have super class, then it will catch all of them. Okay. So it will never go to subclass. Okay. Okay. Well, at given time, only one object is thrown, remember, and it is like an if statement. The first one which matches will be executed and the rest will be ignored. It's nothing uh, different there. Okay, I'm just looking for the lecture notes right now. Okay. uh, okay, so no project update here, come on. Okay. Okay, so now we talked about this. The only thing we need to talk about is just the last slide, which is basically we did discuss all of this, and and so that's what we did just now, the demo. And Java also offers you assertions. Assertion is a statement in Java that enables you to take your assumptions about your program, and they are useful for checking the precondition, postcondition, class invariant, internal invariants, and control flow, and so on and so forth. That's a very good document here which you can follow and read. It gives you some examples here. In a way, when you're using JUnit, you're also kind of trying to achieve something similar. Evaluating assertions should not result in a side effect. Whenever you're writing this kind of assertions, they're basically making sure to check that your current state is a valid state. You're satisfying the criteria, precondition or post condition, or that your invariant is always holding. So you're not changing the state, but you are simply checking your state. That's what our aim is. Okay. Now, so generally speaking, for backward compare, by default, Java disables the assertion feature. So you need to enable that using these command line arguments. And the idea basically, assertions, what they really do is, this example kind of highlights that. So here is an example which basically said assert is a statement, as you can see here. It's in a red color, purple color, whatever. Now, importantly, this is a Boolean expression, and this Boolean expression must be true. Okay, so it says this is, I want to assert that in this example, this variable is greater than or equal to 0, and that is less than or equal to blah blah, whatever it is. It's a logical Boolean expression. Okay, so it says that I want to assert that to be true. Now, if it is not true, it will print an error message. Now, when it prints an error message and it stops executing a program, we say, hang on, we want to print some additional information. So what this says is that after a colon, as you see here, okay, we have a variable name here. So we are telling that, okay, if this assertion is not true, of course, terminate, but at that time, it will tell us at that time what was the value of that interval. Because we are curious because we're checking something on that variable. So I just want to know what was the value of that when the assertion was not true. Now you can put other variables also here, but that's just very simple example. So assertions normally are not used that much in Java, but they are quite useful. Now, by all means, you could have if statement here, the same thing, okay? Or you can also throw exceptions. So you can achieve this in many ways. In a way, the disadvantage of this is that if this is false, it will terminate your program and it will print this message. A lot of time you want to handle it more gracefully. So you want to interactively print something or go and execute certain methods before you terminate your program. If the resources are open, you want to close them before you terminate. So you may or may not want to use assertion depending on it depends on your requirement. But it's good to know that assertion statement is available in Java. Okay, so and so forth. Okay, so all these are the links. So if it's all right, then I can move to the next topic. If any questions, please ask me. Otherwise, we move to the next topic. Okay. Okay. So it's basically all about generic types. It's very important. We have already used. You are already familiar with this reasonably, but it would be useful to go through this. So what I'm going to do, I'm going to go through all the lecture slides, conceptually explain what this are, and later on we'll go through one example. Okay, but a lot here is just for you to understand conceptually, and please ask me if you have any questions. Okay, and I've tried to capture most of the things you need to know for this course and also generally used, okay, as far as the generic types are concerned. Okay, so what are generics in Java? Okay, So a good introduction to this is again available as a part of the tutorial. Okay, so you can always, more detailed description is available in the tutorial. Even some of the examples are coming from the tutorial. Okay, here, but we are capturing the essential features quickly so you can go through them here. Okay, but if you want to know more about it, by all means go here and read that. They will explain that in much more detail. So that's just part of that, but we have covered most of the essential parts basically. So what is generic? Generics enables types, which are nothing but classes or interfaces, to be parameter. Generics enable types to be parameters when defining classes, interfaces, and methods. Okay, so we can parameterize classes and interfaces or even methods. Okay, very shortly you will see what we mean by parameterized. So what we do here is that instead of just talking about a collection of integers, collection of strings, we say I have a collection, and at the time you want to create a collection, tell me what type of collection you want to create. At that time tell me create a collection of type integer. So I have a set, class set. Now when I create a new set, I tell what elements I want in that set. So it can be a set of integers, set of strings. Now I can also create my own class, say student, and I can also create set of student. So this is the class I created. Okay, so the idea is that we can basically provide parameters to classes, interfaces, and methods, and the behavior of the corresponding entity will change accordingly. So what are the benefits? It removes casting and offers stronger type checks at the compile time. Now I just want to talk about briefly historically. In Java did not support it in the first three versions, I think, generic types. Okay, now the idea was this: in Java, object class is a superclass of everything. Okay, so they said the following: they say, why don't you simply create a collection of type object, so a set of objects. Now because object is superclass of every other type in Java, in this set I can store integer objects, or I can store string objects, or I can store objects representing student class. Okay, so it says that why don't you create your interfaces classes where you simply use uh, object types, and you can still do that. Okay, I just look if you do, I've not understand the question, Frank. If we do the without generic, so can you rephrase that, my friend? So I don't understand the question here. So there is that. So this is the traditional without generics. Okay. So without generics, what happens is that I have array list. Now I'm not telling what type. So this is array list where I can store objects. Now then I say add hello. I can do that because a string can be treated as an object. I can also add integer. I can also add student if I want to. Okay. Now generally speaking, a collection will have only one type of objects. Generics are only useful when you have only one type of objects in the collection. If you have mixed type, by all means you need to still go to object type, but then it's too confusing because you don't know the first element is a string or integer and how to deal with that. Okay, so now it's not polymorphism as we know it. Okay, so we'll talk about that. Just follow the slides and you'll see the advantages. It's not necessarily polymorphism. So the question now is that if you look at this, so I can put string. So this you can still do. Nobody stops you doing it now. But the disadvantage here is that when I get the corresponding element, it will return, and this is what you need to understand. This object is of this return object is of the type object. Okay, I missed my pen here, by the way. Okay, so yeah, so uh, okay, I just read that analysis. So is that the benefit of not using generics? So, okay, frankly saying, I have been doing the generics version since that is what the starter code has had in most labs. And yes, we are also using in the lecture notes. And I didn't know you could make list of both strings and integers. So I think let's wait and go through some examples. Okay, we'll go through some examples, Frank. So I think it will be clearer. And then you can ask me if still it is not clear. So the idea now is that this is of type object. So if I want to treat that as a string, I need to cast it. Okay. So if I treat something as of type object, the casting is a problem. So that's what I say. It removes casting. So if I don't use generics, okay, then basically I need to do casting like this and constant remind. That it can achieve that. That's an overhead. Generic example, and we're going to go through many examples shortly. But in plain English, it says you create an array list, whatever collection you have. Now you see here we can provide parameter to classes, interfaces, or methods. So what is parameter here? This is my parameter string. So I'm saying is that create an array list where every element is of type string. So remember, in this every element must be of type string. I can't mix and match if that is what somebody is asking. However, tomorrow I can also say array list and then integer here. So that list has got all the elements as in integers, or array list student. So it's an array list where every object is of that particular class type. So this can be changed to whatever class or interface you want to provide. That's a type, which is just a parameter. So this is the parameter which I can change as per my requirement. And this is nothing but a class or an interface. And you can use the existing, or we can create our own, doesn't matter. Okay, that's first thing. Okay, so now I get it, then I don't need to cast, you see, because it knows that every element here is of type in string, so I can automatically use that as a string. No casting is required. Okay, now let's go through a generic type. So a generic type is a generic class or interface that is parameterized over types. Okay, now a generic class is defined with the following format. So normally it's the class, name of the class. Now, just like we have already used it once, so we have that bracket, end of that bracket, and in between we are saying these are the types user need to give us before we can create this particular object of this type. So these are the type T1, T1, T2 up to Tn, whatever. These are the types. What are the types? Nothing, interfaces or classes. Okay, so these are the types user need to tell us before we can create an object. Now you can actually write any characters here. Okay, but generally speaking, if this refers to element, we normally use E. We are using K, that means we are referring that to as a key, N as a number, T as a type, so on and so forth. So these are just the notations we normally use. You don't have to, but that kind of, you know, tells us that, well, this is basically, this particular type represents the key type, number type, or this is just a type, so on and so forth. Okay, so here is an example. Okay, so normally I create a box. Box is something you can store a value in. Okay, so originally without generic type, I say I have box, I can put object. That means I can put anything here. So user basically creates that object. When you say set, user will give me the object and I'll set it. Remember, this object could be any type. I can store integer, everything, but then I have to cast it back. That's my problem. But generic version would say, I'm going to create a box, but you tell me what you want to store in that box, because later on you will be only able to store that. You can't store anything else after that. Okay, that makes it clearer. Your code is clearer now. It knows exactly what type you expect from that particular box. and even at compile time it will give you error message, which is quite healthy rather than having error at runtime. It crashes and there's much more problem. So a lot of time we want to check these things at the compile time. So it says user will tell me the type they want to store in this box. So now I create a variable of type private, qualified private. Now you see what is the type of that variable, the type which user is going to give me. This is exactly as this one. So if the user gives me integer, it will be integer, string it will be string, or student it will be student, customer it will be customer. Now this is the classic variable. So now I say now set is also t. So whatever user gives me is all replaced by all these t's here. So you see now that particular box. So if I say box integer, now I can store integer value on that only. If I say string, I can store string there. Okay. Now, so generally the good idea is I'm not reading the comments, just to explain this first and then I leave the comments. Now the first thing is that new box means that I create a box of type integer constructor. I mean, if I this is a constructor with more argument, I need to prioritize them, and then I store into the variable. The variable here also is of type same. Remember that box with integer. So that's that's the ideal you want to write. But of course, there's so much typing here. So Java says, it can infer type. So technically, even if I say this, so what compiler does, okay, you want me to create a box. I don't know which one, but I know that if you want to assign that to a variable of this type, that means you must be referring to integer type. So it will infer this type and it will put it here. So in many cases, Java is smart enough to infer types. Now, if you're happy with that, you don't need to explicitly write. Okay, so you avoid, otherwise you have to write both for integer. Here you can skip one and write here, it will infer this type and create box with integer. Okay. Yeah, the idea that you have to have a list with different type is basically, unless you really need it, it's not a good idea. Otherwise you need to remember exactly which element is of which type. Okay. So generic is basically not that I can store everything. Generic simply says the box either is of type integer or it is of type string. If I have array list, then every element is either of type integer or a string or a customer or a student, but only that one type. There are no multiple types there. But I can create multiple array list where one array list is with integers, one with string, and so on and so forth. Now you see here, I can also provide multiple types. So it doesn't have to be one type. So here interface, similar as a class also it could be. Pair, now we say user needs to give me two types. Now I could have said T1 and T2 by the way. But we deliberately use K and V, so key and value. So it kind of meaningful here. Okay. So we know that first type refers to the type for the key. The second refers to the type for the value. It's easy for us to kind of understand. Technically, I could have written T1 and T2, but as far as you follow the notations, that will be useful. So then it says, see, this is interface. So it says the method get key should return type K, this V. So, I mean, pair is generically defined. And as you will see the example, how we can utilize it. Now, I have a class, which is ordered pair. It says it. Now, the class has these two parameters. Before you create instance of this class, you need to provide two types, one for key, one for value. Now it implements this interface, which also corresponding. So you can see now, hopefully you can follow logic right now. So you see, I start defining this class without in fact knowing what is the type of the key and the value, but I don't need to. Okay, because whatever user tells me, if it is string, it will be string, if it is integer, it will be integer, so on and so forth. Same thing for the value. Okay, and now this should be intended by the way. So now ordered key pair is, again, you give me key and value and I'm going to go and store it there. So this is just a constructor for this class and get it. Now of course you can add many more methods here, but this is just showing you that now you're creating a class and the class will require two types to be given, and based on that it will store this type, and it has a constructor, it has a get method, you can have set method and other methods. Now how to use it, you see the examples now. I can create a new ordered pair. So right now I say key is of type string and the value is of type integer. So then this is the constructor. Now the constructor has got, remember, these two values here which are of the same type. Because the first one is a string, that has to be string, by the way, as you can see here, and correspondingly second one will be also integer. But when I create another pair, it is string and string, so this is also string and string. Okay, so got it. So that's one way to do it. Now again, you can ask Java to infer types. So you can basically say order, I don't want to keep on writing, but it will then infer type from the left side. So this has to absolutely match, otherwise these two, otherwise you will have error message. Okay, so it has to match, otherwise it won't work. And it doesn't have to be the types which are already there. You can have a string and you can actually provide an object of some other type. Okay, so new box of type integer, so it doesn't matter, it's just an object. Okay, and so this type is string and the value is actually that type, that itself is a generic type. So you see, when you see lots of brackets and lots of this thing, just step by step try to infer the importance. So the key is of type string and the value is an object of type box, but that also must be of type integer. Okay, got it. So if you have asked me, if you have questions, please ask me. If you go through these examples, it will really clarify a lot of issues you may have, queries you may have. Okay, the generic methods are that introduce their own types. So generic methods just like classes. So here, look at this class. Now the method here is compare, and we're going to use this compare, will come in other discussions also. So the method is compare. It returns the value boolean. So that's our core method. The method name is compare. It returns the value boolean. The question now is that before you write that name, we are asking user, let me change the color so you can easy. We are asking user to provide us types K and V, two types. Okay, basically one for key, one for value, because they will be used in defining the rest of the method. So you can see here, now I say, what is the first argument? So the first argument is P1, second argument is P2. But then what is the type of P1? So the P1 is nothing but a pair of type K and V, and K and V must be provided by the user before the user calls this method. Okay, and similarly P2 is also similar pair. Now what I'm going to return, I'm going to compare these two pairs. So if the key values are different, so I get the key from P1, and if it equals to P2, if both of them are equal, okay, and so it compares. So if both are equal, if the keys are equal and the values are equal, I want to return true. If any one of them is not equal, I want to return false. Now this logic is whatever you want your logic in for your application. Okay, that's not the issue here. The issue here is that now I have defined a compare function which compares two pairs where the key and value type is whatever you provide, and that's the power of this. So now I create a new pair. As you see, I'm creating a new object. So I'm creating a new pair, and in this pair you see I'm only providing this, so it's integer and it's a string type. Pair 2 and string type, 2 and pair. Now you see here, this is class util. Now this is a static type, just to make it easy for you to understand, but you can also do the same thing for instance type. So static type, so I write class name dot the method name. So I have class name dot. Now before I type the method name, I need to provide those parameters. So this is key is of type string, and values of integer values of type string, and then it will assume that p1 will be integer string type, p2 must be also integer string type, otherwise at compile time it will give me error message. Yeah, Yusuf, you're coming and discussing all of this shortly, okay? Yes, you can. So the type, so if you really look at the slides, I've captured essential part even more than what you normally use. And if you understand these lecture slides, you have understood a great deal about generic types. Okay, so let me just go through them. So the type has been explicitly provided. So this is easy for you to understand first time. But you see, so many things I would write. The same thing you can write like this if you want to write. Okay, so I create the first pair, I create the second pair. Now you see what I'm doing here. Now I simply go and compare. I'm not giving any types. You see, this is important. So what Java does, it will look at P and say, what is P? P1, sorry. So it says P1 is of this type. Then P2 is also of this type. So then it automatically infers type, which normally otherwise we should have added here. So this is inferred now. So generally we don't write that because it is inferred by Java. But having said that, if these two pairs are not of the same type, it will create error message even at the compile time. Okay, so that's the advantage of this thing. However, if they are the same type, then it will compare and this will be Boolean value. Okay, so please go through these things here. Now, this is, I think, what Yusuf is talking about, the bounded type parameters. So the idea is that so far I'm saying give me the type, which is basically K and V. So K can be any type you give me, V is any type you give me. But more interestingly, what we can do, there may be times when you want to restrict the types that can be used as a type arguments in the parameterized type. So the question is that I say, now you already know that I can provide type as a parameter. But can I say, don't give me any type, the type you give me must extend, the type you give me must extend the number type. In this case, there's a number interface or class, whatever. So what we are doing is that this type must be the subclass of number, or it should yeah, in this case subclass of number. Okay, so the idea is that the method that operates on numbers might only be want to accept the instance of number or its subclasses. Okay, so now whatever that type is, and then I go and write. So this method is very extended. Okay, so this one again, t extends integers, so everything which is a subclass of integer, for example. Okay, got it? So you can restrict the type. What is the advantage of this? The advantage of this is that, say, in our example, I say give me any type which is subclass of shape. Okay, now because the shape class offers me get area and get circumference, for example, so whatever type you give me, I know those methods are already available. So this type will give you some methods. So whatever type this, because it is subclass, you are guaranteed to have all these methods available, and so you can then use that in your problem solving. So it says give me any shape, so it's a give me any type, but however it should be extending the shape class. So now what happens is that I know those two methods will be there, so accordingly I can use them. So this really provides us that given object will at least support the corresponding methods which are required for your problem solving. And this is also a nice way of solving it because we are not asking a particular type. So user can create subclasses for whatever reason and can still call your method. They don't need to basically provide a fixed type here. Okay. The other thing is that any type provided, if it is not extending number, then we don't accept it because we are not guaranteed the corresponding methods will be available. Okay. Now, a type parameter can have multiple bounds, doesn't have to be one bound. In previous example, there was a one bound. Okay. So this one bound of number and integer. Okay. Now, in fact, I can have multiple bounds. But remember, it's a single inheritance system. Okay. So when you have B1, B2, B3, only one can be class. The rest can be interfaces. You still use extends, but they can be interfaces. So in this case, it must either be subclass of one of the class here, the rest must be interfaces. So they T must implement those interfaces. Okay, a type variable with multiple is a subtype of all, and the types listed in the bound. Note that refers to interface and classes. There can only be at most one class, and the rest must be interfaces. Okay, so obviously, okay, and one of the bounds is a class. It must be the first one. So if all of them are interfaces, then it should implement all of them. If one of them is a class, it must be the first one, the way you write. Then the rest of them are interfaces. All of them can be interfaces also. So all we are doing, this is very, very useful. All we are doing is that by putting all of them and say, whatever type you give me, it must implement all the interfaces. That's for example, all of them interfaces. And each interface will give you set of methods. So now you know that object will offer me all the methods. Off you go and use them accordingly in your method. So that's very nice way of communicating what you expect from the user. Okay. So generic methods and bound types and parameter. Now let's take the classic mistakes people make, and this is where compare and comparable, which are extensively used, we need to talk about. Okay, is 257. So I think I'll take a break for 5 minutes. Okay, and because we'll go through this example, so I'll start after 5 minutes, by the way. So maybe 2 or 3 minutes past 3, I will start, and we'll then continue finishing this set of slides. Okay, so I'll take a break. Okay, I think we should resume. Um, okay, so I'll quickly go through all the lecture slides and then we'll go through an example, okay, and then we'll talk about briefly iterators. I think that's what we should be doing today at least. If we can't cover the decorator pattern, I will start on that if you got time, okay? And we may have, because what we need to do now is rather straightforward. We just need to know what it is. So please understand. So now, if you look at the generic methods and bounded types, a lot of time we end up using bounded types, okay? And the question is that why we need to use bounded type, and this example is actually quite a good one. So let's assume I want to write a method. The name of the method is count greater than, and it returns the integer value here. Okay, it returns the number of values which are greater than the given value. Now, what is given? You are given a array. Now, what is the type of the array? It's array of type T. Okay, you are given an array of type T. Okay, so that's what you are given. Okay. And you are also given element of type T. So the question is that I want to check whether this element is in this array or not, because both are of type T. So simple logic you may apply is that you have a for loop, that's fine. Now the question is that because if it is of type integer, I can compare it like this. This is comparison is already implemented part of Java, but that is only for the primitive types like integers and floats and so on and so forth. Even for the string, we can go and use corresponding string methods, but we can't use these operators. So this is only applicable to the basic types. But what if T is of type customer? How can I compare one customer against another customer? I can't use this operator. So that is not valid. So what to do? Because now it's a generic type, we don't know what this type T is. So now, what we are going to go through one example later on is that this is quite a useful interface already available in Java. The name of the interface is comparable. Okay, and so it is an interface which says that anything of type comparable, which is a parameterized. So comparable must have been given a type. So anything of type comparable, okay, and example will clarify this further, must provide a method compared to. And so, and when you see example, you will see very much easily how to use it. Okay, but all it says is that anything which implements comparable must provide the method which allows me to compare the current object with another object of the same type. This is another object. So this comparator will compare the current object with another object given by somebody. Now remember that the type is T. So it says that you must, any class which implements that must offer compare to method. That's in plain English. So now this is getting very interesting, and this is where it will check really you understood what we discussed so far. Otherwise, please ask me the question. So now the method name is still the same. Okay, my method name is still that. Okay, now what it returns is that there's no change there. Array is also the same, no change. Element is the only change. Before I was simply saying give me any type T. Now I say no, give me the type T, and this is where the whole difference is. Give me the type T, give me the type T, which basically extends a comparable type with the parameter T. The interesting part here is that this is T and this is also T. So it says that give me the type T which extends comparable of T. That means give me the class which implements, if it is string, comparable string, if it is a customer, comparable customer. So I can compare two customers. So this is a very elegant way of saying give me a class which implements this interface, meaning that class must offer me compare to method. And the compare to method will compare the current object with a new object of the same type. Okay, so now you see this solution is now here. Same thing. Now, when I want to compare, I go through every object in my current array element, which is the object basically. And now, because that element is of type T and T extends comparable T, it will have compared. So all I need to E dot compare to, I'm guaranteed to get that. So I'm comparing E with a given element. And so if they are same, if it is greater than 0, now the compare to method returns integer value. So if both are same, then it is 0. If one is less than the other, then it is minus. One is greater, it is greater. You can look at the API for this and it will tell you. So there are three values. 0 means both are equal. Negative means one is less than the other. Greater than 0 means one is greater than the other. Okay. So in this example, I'm simply saying is that greater than. So if the value is greater than 0, okay, so I'm saying, okay, the element I have is actually greater than the element you're giving me. Who decides it? Well, that's implemented in this method in that class. We don't even care. Abstraction at its best. So this method will work for any type to count the number of greater element compared to this, as far as that type implements this interface. Okay, so you will see a lot of these generic methods like this where you restrict the type such that it offers all the required methods to carry out whatever task you want to carry out. In this example, it is compared to. Tomorrow it could be something else, whatever you want to do. Okay, but that's one of the tricky one, and if you have any questions, please ask me, but that's what you are really doing. So it's very long header, but if you split it up, it's not that difficult to understand. The question is, why do you use extend in place of implements? Well, that's up to the Java designers, by the way. So it's not our say. So that's how the Java is. Okay. So okay, personally I agree. Extend is confusing because extend has got two meanings here. Okay. But you're right, Mike. There are quirks in every frameworks in every languages. Okay. And therefore, always you have group of people who love something and the others uh, technically would hate, and there's some in between. I think you just need to be neutral, appreciate what the good things, and know what the limitations, and use to the best of your knowledge, and that's it. I personally never associate that much with one framework over the other, even though you need to know inside out the advantages and limitations of each one of them. Okay, so consider the following method: generic, inheritance, and subtype. So now we are getting into, well, all the generic types and everything, what happens when we have inheritance, subtypes, how they behave. Okay, so these are classic mistakes people make. Okay, and so we just go there. So let's assume we have a public void box test. So obviously that's a method. Okay, now the argument is, come on, yeah, n, which is of type box number. Got it? So there's a method and there's one parameter or argument here. Okay. Now, what type of argument does it accept? Box number. Are you allowed to pass box integer or box double? Why we are asking that question? Because integer is a subclass of number, double is subclass of number. So a lot of people think, yeah, that should be possible. But as it says here, this is red big no here. This is not legal. Okay. So this will only match box number. If this type is subclass of number, that's completely different interpretation for Java, and that's how Java does. Okay, so the answer is no, because this and these are not subtype of that. That's how it is treated. Okay, this is common misunderstanding, so therefore I'm talking about. So the idea is that integer is subclass of number, but that is not. Having said that, both of these are of course subclass of object, so that's fine. Now, generic classes and subtypes. You can subtype a generic class or interface by extending its implementation. So this is a class. Okay, now I can extend that class. So list is a subclass of collection. But important thing to notice here is that this is a string and you see here this is also string, that doesn't change. And you see here, sorry, yeah, it doesn't matter, okay, you should know what I mean. So this is also string, okay. So all of them are strings. So then I can subclass. Okay. The relation between the type parameter of one class or interface and the type parameter of another are determined by the extents or the implements. Fine. The interesting thing, array list E implements this, so and so forth. Okay. So array list string is a subtype of list string, so and so. As far as the string, the type, not string particularly, but that particular type doesn't change. As long as you do not vary the type, that's the important part. It's fine. You can't change the type. Okay. So collection string, string, string. You can even add more types, but that type should not go. Okay. So that's the bottom line. Okay. So I can PE and extend E, and I can even add another type, but I can't change E to E subclass, for example, or completely different type. Got it? Now, what you will see a lot is this one also now, wildcard upper bound. In generic code, the question mark called a wildcard represents an unknown type. Okay, so I don't know the type. So the wildcard can be used in a variety of situations as a type of parameter field or local variable, sometimes even as a written word, and you will see a lot. So the upper bound wildcard, where foo is any type, matches foo and its subtype. Okay, so this one, sorry, it's a bit slow today. So this one matches anything which is foo or foo subtype. Okay? You can specify an upper bound for wildcard, or you can specify lower. You cannot specify both. Okay, so as you see, that's upper bound. Next slide is a lower bound, but of course you need to have one of them. You can't have both of them. So this one again says n. So list. This is the list of type. Which type? Well, any class which is a subclass of foo. So foo or its subclass. So this variable is a list where the type is foo or the subclass. Okay, same thing. Any number or the subclass of the number. Okay. Now, the unbounded wildcard type is specified using the wildcard character this. The example this is unbound wildcard. So this is no extent here by the way. Okay. This is called a list of unknown types, which is different to the extent right now. Okay. And there's subtle differences, and you will see shortly. So you see here, I say list of object. So that's a type now. So this variable is nothing but list of object. That is different to list of unknown type. These two are different. Okay, so that's what you need to understand, that these two are different. They are same. Okay, they are not same. Okay, so basically, it prints only the list of object instances. It cannot print that one. So because even though integer is subclass of object, they are not the same. Okay. Well, you have to put something inside, otherwise it doesn't work. You have to have a question mark or a particular type. Okay, and this one basically says now this can be replaced by integer, whatever type you give, that type will be then used in this type. Okay, so in this case, this could be, so I can write this to write a generic print list. You write this because then question mark can be replaced by any type. So I can call this for list of integer, uh, uh, or list of student customers, so and so, everything one, not this one. This one is only list for objects. Okay, so there's a subtle difference between both of them. Okay, okay. The upper bound wildcard is kind of similar thing. This one says this one is a super of that. So the lower bound card expressed using the wildcard this followed by super keyword. Similar, so I just keep it quickly. It's other way around. Okay, something is a super type of A. Okay, so that's the method that works on list of integers and the super type of integers. I say, so this one is any type which is integer or is super type. Okay, okay. Now, so again, example, again we discussed it before. If you have this, it can be it can be used to match list of numbers, list of integers, list of customers, all of them. That's fine. Okay, the common part of so this one, sorry. Okay, So this is basically declarations of the list. Now remember that I can say list this extends number, so and so forth. Okay, and this one is super. So all of these are possible basically. Okay, because remember that this can be replaced by integer, or this can be anything which is restricting this. Super or extend will restrict, but the type is not known, so that's fine. We can have a particular type. Okay. Okay, so I'm not reading the comments. Is anything like that? So the collect. Okay, so that's it. This basically covers most of the things you need to know about generic types. And of course, every language will have a bit more involved information for that particular. But remember that this course is not about knowing nitty-gritty of Java. It's about knowing Java as far as is relevant to our course. And whatever we need to know for our course is already part of these lecture slides. And in fact, it does cover most of the topic you need to know for majority of the problem you may come across in Java. Okay, but still it may be useful if you are really confused to go through some examples in the tutorial. Okay, so what are the collections in Java? Okay, so again, earlier versions of Java, and there were no collections. Okay, and the later versions, of course, now for a long time, collections are available. So what are the collection framework is a unified architecture for representing and manipulating collections. So the idea is the following, and in English, the idea is this: a lot of time in our programming, we create a collection of something, in a collection of keys, collection of key value pairs, collection of customers, students. We then also need to sort this collection. We want to search through this collection. We want to add something to the collection, remove something collection. So these are the tasks we need to carry out again and again. So any decent language like Java or C++ or C# and all of them, they will have a very rich library. So you don't need to implement lots of things from scratch. So in fact, a lot of things you learned earlier in the data structures, for example, once you know Java and you know all these libraries, you never need to implement B plus or AVL tree or any sorting algorithm, because most of them are already available in the library. So the collection framework basically says that now that's just only tells me that I should have a collections, easy way of creating collection, manipulating collections, sorting, searching collection. So that's the aim we want to do. The other purpose of these frameworks, okay, is that, hang on, can we, instead of just creating separately collection which represents SAT, collection represent hash table, we can do that independently. Can we put it under one framework so that it is easy to interoperate between collection types? So for example, I can create a collection of array list, and then can I quickly convert that into collection of tree set? That then can convert into hash set or hash map, so on and so forth. So I will go some of the collections which are already available. So the idea is that you can create one type of collection, and can you quickly create another type of collection by simply passing the original collections. You don't need to rewrite the code. So for example, every collection will have a constructor which will accept a type which is collection, which is the generic type in this framework. So the idea is that every classes in this framework, which represent collections, will take something of type collection, and then they will convert into corresponding type. So I can easily create array list and then just provide that and create another type of collection, because I'm guaranteed to have the corresponding constructors and the other methods. So there is uniformity in which we can create objects of type collections and change from one type to another type without much problem. Of course, you need to carry out some task for that, but it will be much more easier. Okay. So a collection is a simply an object that groups multiple elements into single unit. Okay, all collection frameworks contain the following: interfaces allow collections to be manipulated independently of the details of the representation. The classic separation between interface and classes, as you will see in the next slide. Implementations are the concrete implementations of all the collections. And the next slide will make it very clear what are the interfaces, what are the implementations. Okay. Obviously, we can only create class objects from implementations. So we first decide what kind of interface we want to use, and then we look up the APIs and realize this interface is implemented by that many classes. And we can pick the one which is suitable for our application and create a class and start using it. Now, it also offers many algorithms, many sorting algorithms, and so on and so forth. Okay, the methods that perform useful computations such as searching and sorting on objects that implement collections. So it already offers sorting algorithms. It says you give me a collection and give me element, and it will just sort it or search it for you. Again, you don't need to implement. So it really helps you a great deal. The algorithms are said to be polymorphic because depending on which algorithm object which object you create at which level, the way it searches can change, the way it sorts can change. We can decide what kind of sorting and searching we want, so on and so forth. Let's go through the next slide. That's easier. Okay, so the core collection interface encapsulates different types of collections. The interface allows collections to be manipulated independently. So that's the collection type. So at that level, it offers the general purpose methods you need for collection. Then it's a set is also a collection, but obviously in the set, when I add something, that add operation must make sure that there are no duplicates. In the list, I don't need to do that. As you know, queue will have a different way of adding and removing and so on and so forth. Okay, then sorted set can also be there. So the idea is that the methods of each collection should have all the methods which are available in collection interface, but then you can have more specific collections and even more specific and so on and so forth. This other one is got a map, which is key value pair. Okay, and which is used quite extensively, hash maps, for example. Okay, and the other one is a sorted map, where it is also sorted, so you can paint it accordingly. Now, these are the generic types. More interestingly, will come later on. A collection represents group of objects known. Okay, collection interface is used to pass around. This is important. Collections of objects where maximum generality is desired. So I can pass around the collection objects, but because they all are implementing collection interface, they all will offer the corresponding method. So it's much more easy for us to manipulate them. By convention, all general purpose collection implements have a constructor that takes collection argument, you see. Okay, and you will see that example shortly. Now, a collection interface must offer all these, and this is where we are going to go today, time permitting, what are the iterators. Okay, so what this one says is that every collection, whether it's a set or a map or a list or a queue or a stack, whatever, it should tell me the size of it, it should tell me it's empty or not, it should check whether it contains particular element or not, it should allow me to add something. Now, how do you add, how do you remove will change, but so on and so forth. So you can look at this API, and it will basically show you everything you need from their interface. Okay, so if I go there, and this is what you should be doing, so that's a collection interface. You should read this. Okay, so it goes through all the examples here and shows you how to use and traverse through the collection. I'll go through one example, but you may want to read through this because many good examples are available here. I'm going to talk about iterator later on today. Okay, so these are the collection interface. Bulk operations contains all, add all. These are the new operations for that, so on and so forth. Okay, so you may want to look at that now. Okay, this is interesting. Okay, so now these are the implementations. The general purpose implementations are, so these are the interfaces. So these are the different collection types Java in these frameworks that are available. So one is a table, as you know, key value pair. The other one is a resizable array, which is the array list which you are used to, which is nothing but implementing this particular interface. Then balanced trees interface is already available, by the way. And with this, you have tree set. You see here. So tree set is a class which implements set using balanced tree. This is already available here. So it implements that interface balance tree, and it offers functionality of set. So tree set here. Tree map. So I use balance tree to implement map. So yes, hash map is very popular, but sometimes I think tree maps are even better because they use balance tree. So the insertion is extremely like log n, as you know, so which is pretty close to constant anyway. Okay? But then there is advantage because you can traverse through the values in a particular order because trees are already ordered on the key. Okay, but a lot of time hash maps are used, and there are also so-called linked hash maps. So where I can use it as a hash table, but all the elements are also linked in a linked list. So I can also traverse through each and every element as if I'm traversing through the linked list. Okay, so these are the types interfaces. These are different uh, functionalities which, and the one in the middle one offer. So linked list offers this list. Queue is also the same, so you can understand what I'm talking about. Okay, so that's what we use a lot because that's much more easy to use, but there are all these also available. Okay, so some of the good ones are, if you want to create a set, just have tree set. That's very efficient. A lot of people use hash map. All right, you can also use tree maps, which is basically hash map, but there's underlying, there's a balance tree there. Okay, you can also use that, so on and so forth. Hash set also there is available. Again, you can go through this, and it gives you the overview of the collections thing. Okay, uh, the wrappers for the collection classes. So this all are discussed much more detail here. But you see, for this course, we already use array list, and similarly you can use other ones. Okay, it's not that complicated. You know, once you want to use it, you just go and read this document, and it tells you go through the example, and that will be much more clearer. Now, before I go to the example here, I want to show you that the 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 important thing about these collections is that I have a collection, and how do I carry out certain operations on that collection, and how can I achieve the required flexibility. Okay, so our focus is going to be on, okay, let me close this. Uh, okay, see collection here somewhere. Okay, it's here. Sorry, my collection. Okay, I don't know why it is. So if I'm not able to change it. I'm not able to change the size normally. So if I do this, can I do it now? Yeah, okay. Okay. So now huge lag here. Okay. Come on. So okay, quickly we go through this. So first of all, remove that example of comparable or compared to. Okay. So now, let's say this is a customer class. Okay, and it just offers classic method customer class. So that's not very important. It's a name and rewards point postcode and so on. So of course, name can be first name, last name. I mean, this is just a simple example. So you have a constructor, a customer class. The only difference here you see, it implements comparable customer. So what is comparable? So if I want to go and show it to you, it is an interface in Java language. So comparable is an interface. So anything which implements comparable, in our case, T will be replaced by customer. That must implement, remember that example I discussed in the lecture notes, it must implement compare to method. And so the idea is that, what is this method? If you look at the API, it says that if the current object is equal to the given object, you should return 0. If the current object is greater than the given object, then you return greater than 0. If the current object is less than the given object, you return less than 0. Normally it's -1 and +1, but it's basically positive or negative. So now, if I go to customer, because I'm implementing that, I need to provide compare to. Okay, so if I go here, you see here, I have already implemented. I've saved time. Is a bit slow right now. I wanted to show you by typing, but I think it's too slow today. So compare to method, basically, of course, in our case, T is of type customer. So this will be customer. This is T, which is customer in our example. Why customer? Because I'm implementing comparable, that's my T. Therefore, the argument in compare to must be also T. So this is the other object given to us. Okay. So now I don't read this comment. I'll come back to that later on. So now all I need to do is that if go to this object, get the name. See, the way I compare string is simply I just use compare to from the string, for example. Okay. So don't confuse here. This can be any comparison you want. So tomorrow, if I want to compare based on the postcode, I can replace this by the postcode. Maybe that's easier for you to understand initially. Now I'm saying is that just what you do, take the two postcode and deduct one over the other. So remember, if both are same, this will be 0. If this postcode is greater than the other postcode, that's fine now. It's not frozen. Slow, but it's fine now. I can see my both screens are fine. So if they both are 0 equal, then it will be 0. Otherwise, if this postcode is greater than the given one, it will be positive, otherwise negative. Okay. Okay. Now can you refresh that? I think it's working. When I can see the new screen here. Okay. So basically, the idea now is that I can provide the way I want to compare two objects. Okay, you may want to refresh if it is stuck. Okay, so the idea now is that these two this criteria we can decide. I can compare two customers by comparing the postcode or their name or even some complex criteria. So I decide how do I compare two. Okay. So what's happening? Totally black now after I refresh. Okay. What I'm going to do, I'm going to record that in case I need to put this one. It's fine. Okay. So these onwards, if some problem there, I can put this recording. Okay. Okay. So can you refresh that? I can see it. Like, I see the screen I'm sharing with you in the other window. And so it goes through the system and comes back. Okay? And so I can see it's been refreshing there rather quickly right now. Okay, so that's a comparative. So how we use that is that when you go to test one now, okay, so now you see that test one, okay. Now forget about the first part. I create a new tree set. You see here, so So guys, I'll okay. I will. I can see it is refreshing for me. Uh, you may want to log in again, guys. I don't know what I can do. I can see everything normal. Okay? And as I said to you, one of my screen which I see is actually coming through Blackboard Collaborate. So and normally it reflects what you see also. So try to do it again if possible. Otherwise, of course, this recording will be up there. In the worst case, I just 2 minutes ago recording my screen, so I can at least put that part. So if I continue, because we need to move on, if you can just refresh the screen. If I try to reconnect, my friend, it's only 20 minutes to go. And let me tell you, yesterday, okay, I may refresh it if you want. Okay, guys, can you? You can't see because it is not sharing anything right now. Okay. Now I'm crossing my finger and hopefully you will see my screen. Good. Good. Okay. So I didn't know what happened there. Okay, good. So we're back to business now. So just quickly. So now you see here, I am creating a tree set here. Look at that first. Okay. So I'm creating a tree set. So that's my tree set. That easy. Now the type here is a type customer, scene for type. So I just create new customers and I just add to my set. So that easy it is. You have created a set which uses balance tree. Oh my God, it's too slow. Okay, and so it is all so easy. Is okay to basically just create a set. Now, just to show you how easy it is to go from one collection to another, for some reason, I don't need to for this particular application, but I'm just going to show you. I want to create a new array list of type customer. Now, what I do, I simply provide the earlier collection in a constructor. Remember, every collection can accept another collection. So now the same thing is available as an array list. It's a separate copy, obviously. So going from one collection to another collection, of course, you're copying and creating a new collection. That's fine. It's just do new the corresponding collection and provide the one you have in the constructor. It will work. And then I can just print everything in on the screen. So this will simply print. I haven't done anything. Okay. Now every collection also offers you, okay, okay. Before I want to show you something, okay. Now there is a collection is a class, as you know. It offers a static method sort, and it says you give me a collection, and you don't need to give me anything. Just give me collection. So it says you give me the collection, in this case this one, and collection can be a set or array, it doesn't matter. It will sort that. So it will use the default sorting algorithm, and of course you can use particular if you want, but it will sort. But you must be thinking, well, how is it going to sort it? It says it will look at the elements. Remember, it already knows this is of type customer, and customer has already implemented the type compared to. It is already implemented comparable interface. That means it has got a method compared to. So it will use this method compared to compare two objects, and it will sort. So whatever logic is here, it will sort objects based on that. So tomorrow, if you want to change the comparison logic, you need to go and change this method. It will compare customers differently. Not an ideal solution, but at least it tells you that there's one default way of comparison I can write here. Similarly, there's a default way of printing toString, remember. So if you just say print an object, it goes to toString and prints it. Similarly, if you compare these two objects of the same type, then it will use this. So these are default comparison, default toString methods. Okay? So the idea back to it is that when I simply go and say this, now I'm going to go and okay, I'm going to go and copy and paste that. Hang on, what's happening here? Too slow. Guys, it's annoyingly slow. Okay, delete. Okay, stop. Delete. Okay, paste. Okay. So now all I have done is that I say go and use the sort method available in a collection. But remember that sort method is simply go to that object and use the corresponding compare to method. So this will now currently it is comparing on the postcode. So first the collection will be already in the sorted on the postcode. Okay. Then now let's focus on one first. So if I run this, I haven't talked about the first line. I'm going to talk about that. So you see here, it is sorting 260, 275, 220. So it's sorting on the postcode. Okay, so that's the first one we did. Okay, we are sorting on the postcode right now. Okay, so because the default is a postcode. The problem with this approach is that, sometimes I want to sort customer on their postcode, sometimes on the reward point, sometimes on their name. This approach requires that the sorting criteria is already part of the class. Now I can do subclassing and so on and so forth. But the problem that not problem, but this approach basically requires me to create multiple classes beforehand. So I need to know beforehand how many different ways I'm going to compare them and then create accordingly subclasses. Okay. But then particular class can only compare is only comparable by one way, which restricts it. I want the flexibility so that every customer can be compared on a different criteria, maybe in the same function. Okay, so what we can do then in that case is that we actually have another interface called comparator. Okay, now the comparator class, comparator of type T, what it does is it basically has a method compare to compare. Okay, just a minute. Okay. Okay, so basically, comparator of type T, what it does is that it says it will give you a method compare, which is very similar to compare to, but here it says give me two arguments, of course, of the same type T, and it will return integer. Again, if they are same, it is 0, otherwise negative and positive. Now, advantage of this is that the logic to compare to object is now external to the customer class. Okay, so this is just the interface. This is actually designed by Java. This is a part of the Java interface. So we haven't talked about that. So I mean, you can skip it. We don't use abstract interface. We just use interface. Okay, so this is actually coming from the class. You know, the VS Code takes this is actually the byte code. It takes the byte code and converts into the source code and gives it to me. Okay, so that's a quick thing because I don't want to go to a API. It will take time. So this is how you can look at it quickly. So now what we are saying is that anything which implements that, so when I say implement that, so my class this implements that interface. So I need to provide compare method as I was talking to you. So it takes two object of a customer and then returns integer. Now the logic I put is up to me. Whatever way I want to compare, I put my logic there. So that's not the problem. Okay. Now the advantage of this approach is that I can now create an object of that type. See, this is not parameterized. So this object has information about how to compare to customer objects. And so as far as it implements the comparator interface, I can now say collection sort. This is my collection. I say, but use this comparison in your sorting. So this object will use whatever criteria I have defined there in sorting this collection. And advantage is that I can have multiple classes. So I have one class which compares based on their name, postcode, rewards point, or combination of them. I can have many different objects created, and at run I can create that object, pass on for the sorting, and every time I sort depending on the object I pass it. So this gives you what property? Well, it says because this implements that interface, all it needs is a compare method which is of this type, this signature. That's all it needs. It can have other things, no problem with that, but because it is implementing this interface, it must provide compare method. That's all, because it is going to use this method to compare to customers. That's it. So the logic for comparison is in a separate object. You see, this is the advantage. So I'm saying you sort this collection, but the way you're going to compare objects is actually in this object. So this object actually gives you the comparison logic. And of course, I can have different objects representing of comparing. You got it? So that's why this is much more flexible now. So we have a default way of doing it, which we can put in that corresponding class, but otherwise we create many of these type the comparison classes. Now, if this is not enough, you may wonder that, hang on, so all I need to do is create another class, and it only has got one method like this. That's all. Now, this is basically need to say that it's fine, it works, easy to understand, all is fine. But if I don't want to create a separate class and then create an object for that, nothing wrong with that. If you're going to use that comparison quite a bit, I would rather say you create a class like this and create an object of that type. But interestingly, as you will see here, and I'll release this code shortly, okay, if you look at interface 2, test 2 here, okay, basically I can create entire new class on the fly, anonymous class. Okay, so I can say I want to create new class. What is the type of the class? It is going to implement this interface. And then this is start of my class definition. This is end of my class definition. Okay, and in between, all I need to provide is one method, if you remember. So this one creates an object of an anonymous class. This is a technical word for that. It's an anonymous class which implements this interface. So I provide the interface type and then I implement the class here. So this kind of makes it a bit more flexible. Now, I would say you create a separate file. That's much more easier to understand that logic. Okay. I think it dropped out. I can see. And I'll stop here. 4 minutes to go. So I think I'll start from anonymous class in the next lecture. And we'll go from there. Okay, guys. I think the recording also stopped. So I don't know what happened here. Okay, guys. I think it's Collaborate is behaving a bit